Hello, everybody, and welcome to Motion Design Hotline. We're here, summertime fun time. Kyle's out there in Florida. I'm still in a rapidly heating Ottawa. So, Kyle, how's your time down in the sun going? And also, I'll apologize, folks, we may have some bizarre audio synchronization speeds, so let us know how that's coming through. But Kyle, how's stuff going for you down there?
It's good so far. We just got here last night, so haven't fully shifted over into vacation mode yet. But that's good because I'd much rather be here with you fine people.
Wow, take that, family. They don't watch this, so you're safe.
We got a whole week here. We're fine.
Okay, good. Well, today it's very apropos. We're going to be talking about keyframes, while you're down in the Florida Keys. So we'll see how that goes. Kyle, I'm going to keep hitting our audio dubbing here because we seem to be like a strange kung fu film.
I do see that it's probably a bit off. Yeah,
it's a little wacky. So I'm going to try to fix that up. Kyle, tell the good folks what we're dealing with today, and
all right, I will
deal with some stuff.
So I'll lean into some of my jokes that I realized when I was tweeting about this episode. I'm here today on a key in Florida, so that we can talk about keyframes. I came all the way here just for this themed episode. We're talking about keyframes and kind of the real meat of animation on a computer, of course. And so we're going to be digging into, some of the basics of, what it is. But we're going to lean into the graph editor and be looking at the speed graph, the value graph, how you can use those to achieve the different kinds of looks that you're after. And, probably along the way, we'll talk a bit about what those different sort of styles of motion communicate to your viewers and communicate about the objects that you're moving around.
Perfect.
How's that?
Yeah, that's good. Hopefully we've got the numbers at least close. We're going to be in tiny bubbles for most of this time, so people will barely be able to see our mouths. It's going to be wild.
What if we just did this through the whole episode? Would that be more or less distracting?
Yeah, perfect. That's great. That'd be
great.
Way more normal. So, Kyle, let's get into our things that we have prepared. I'm going to jump into my screen, and there we go. Problem solved. We're in tiny bubbles now.
Cool. Perfect. So, yeah, we're going to be talking about this stuff in After Effects, of course. And, I think before we dive into this, should we just kind of talk about what is a keyframe, just in case we have any newer folks watching us?
Well, I guess we should. That does make sense.
Okay. And you know what? Before we get into that too, we should probably say here the thing here at Motion Design Hotline is that we answer your questions, and we're specifically answering. This was one of those episodes where we took a couple questions that we'd gotten about keyframes, about roving keyframes, about working in the graph editor, and we threw them all into a blender to make a beautiful tropical smoothie of an episode all about keyframes. So here we are.
Well, yeah, and there's a lot like all over the spectrum, from some advanced tips that I hope people will enjoy to just some basic things people should know about. I know we're coming fresh off of some other animation video focused day here, so hopefully people will be able to apply these more technical ideas to their works. So yeah, keyframes. These wonderful,
Go ahead.
Wonderful little bits that tell us what a property should be at a certain point in time. Kyle, I'm just going to press play here on this example here so people can enjoy.
Okay.
Looking at it.
Great.
Yeah, you and I both.
Personally, I like to. Yeah, go ahead.
I was going to say we've both taught this concept a lot. So, what's your kind of favorite metaphor or whatever for kind of explaining what we're looking at when we observe keyframes?
Right. I like to call keyframes a value at a time. And there are some advanced examples where you could maybe say that's not 100% accurate, but in general, you are animating some property, usually a numerical value, and you're giving it one value at one time and then a different value at another time. And then the computer moves between those and thus creates animation. And then you can decide how you want the computer to move between those two things. So I can see Evan here is making a couple position keyframes. And so at frame 0, he has one position value. And at whatever that other time is, the numbers are a little blurry here on my screen.
Right.
Whatever that other time is, he has a different value. And so then the computer is just going to move between them in whatever manner you instruct it to do so.
Right. And at this point, they are linear, right? These are just a couple of little diamonds. The default is linear. If you right click on anything, go to Keyframe Assistant and you ease them or ease in or ease out, we will be changing the shape into little hourglass shapes. And now they are eased, which changes the way we're getting from one to the other. And if you observe up here, see this bunch of little dots. You can see that a bunch of them are clustered together up here, then they stretch out, and then they get...
How about you move that second keyframe closer, and so we'll get sort of a better visual of that. Yeah, when you make it really fast, it's easy to see on the motion pad. Maybe make the layer fuchsia or something
nice
too.
And bright. Ooh, a nice bright orange.
Yeah.
This will show up, I hope.
There we go.
So we can see, right? They're clustered together towards the end. They spread out in the middle, and this is a representation of where the layer is on each frame. Yeah, and we call this process interpolating. So when you interpolate between things, this is what we end up with. And from this, right, this is where this easy thing comes everything else. It all flows from this basic understanding.
Exactly. Before we go any further, should we take a second and tweak that motion path too? Because I really love seeing that spatial version of having only two values, but you're really determining how it gets there.
Yeah, so we're going to enter here into the graph editor, right? This will give us one type of curve.
I just meant play with the, use the pen tool on the motion path itself, but exactly.
So we can see here, motion path is just like any other path, right? Like if you see a path, grab the pen tool, bend that path, and we can bend it around. Now I wanted to get the graph open so you can see this weird little dance.
Exactly. Perfect. So there's still only two keyframes there. There's only two values, but every time he wiggles that handle around, he's drastically changing the way that this circle moves between those two values.
Yeah, and this is the value graph. So we're seeing the X coordinate and the Y coordinate graphed on here. We're going to switch over to the speed graph, and you can see that no matter how I bend these lines, it doesn't change the speed, because the speed is being determined by the keyframe itself, which are these influence handles to say...
Ooh, there you go. Evan is an influencer, and so here he is exerting that influence.
Cursed.
Yeah. Our least favorite of all labels.
I guess
you
so.
could possibly apply to either of us.
I would hope that, for all the influencing, for all the numbers, I would hope that I would have more influence in the world. But it turns out it's just a label and doesn't mean anything.
Yeah.
But yeah, you can see that there is a tighter cluster over here, looser cluster over there. So this is the general idea, that when you're pulling these influence handles, we're saying this keyframe influences more. Now this one is influencing more. And if you double click on one of these points, it's going to bring up our velocity, and it's going to say the speed and the amount of influence. And that is going to sort of determine, that's the whole story. It's what time at what value. So we've got time, we've got value, and then we've got how are we coming into that value, and then how are we going to exit that value. And that's the story of a keyframe, right? And
yeah, and really all of this it can be very numerical and technical if you want, but also there's, if you need to be precise, or especially if you need to have multiple things move in exactly the same way, that's when that's valuable. But a lot of times too, obviously, you're just playing with this over and over and over and tweaking a little bit and watching it until it feels right, because ultimately that's what matters.
Right. So, Kyle, natural segue. The feeling of motion. Let's get into your first example that you prepared before singing it. Also, let us know in the chat, how's our audio sync doing? Have I nailed it? Did I no scope that?
Hopefully. Did you influence the audio enough to make it perfect?
We're gonna find out. So Kyle, I'm gonna play this through. I've put a little echo effect on adjustment layer, so we've got a little bit of onion skinning, so if people can kind of see these little shadow sort of shadow selves here are really just showing us where these layers have been on previous frames. But here I'll play it through without, and you can see we've got three balls, three circles. They're all bouncing.
Could you maximize that in the viewer just so that we can
Oh yeah. Hold on. We'll just
see it a little better?
fit it up here. I still want
There we go.
people to be able to see the
Right, of course.
keyframes, because if we're here at the start, they've all got the same Y positional value. And then here, they've all got the same value. And then here, they've all got the same value. But it's
All the same keyframes, but we're changing how they move between them.
And the big difference is they all have different graphs. So Kyle, graphs?
Grabs. I saw giraffes earlier,
Right.
speed giraffe. So we're going to lean into that from, I believe it was Reverb Mike. Thanks for that, Mike. Yeah, so ball number one is quite similar. So you can see the two curves that are almost the same there. That's what those two are. And the one that's really, really super pinched in the middle there is the one on the far right, which has so much what we call hang time that you almost can't even see that it's falling. You can more kind of feel that it's falling from the little bit of movement up top, and you get one frame down at the bottom there because it's just, I pinched it so extremely there to just really, there you go.
So we can enjoy.
So you can more feel that it's dropping versus actually like getting to see any frames. But feel free to tweak away on that, Evan, and kind of like show what a difference that makes when you start playing with that.
Yeah, I want to just kind of say like, oh, let's build a little bit more of a plateau up at the top, right? So, so already we're getting very different type of character here. And one thing I think is really important, we are observing, right? We are observing the value graph here, and that allows us to directly manipulate the handle, right? Up, down, out, in. We can't quite drag it sort of vertically down. It still has to be at like kind of an angle, right? But
yeah,
it is a one-to-one relationship between what the graph looks like and what the value is. So for some people, this makes the most sense, right? Like,
and one thing to point out, we are obviously animating position here, but if you're animating position, the only way you can really work with the value graph is when you separate your X and Y into two different things.
Right. So,
which I have done here.
Which you do by right-clicking on it, and then you click on separate dimensions. It'll break them apart. Yes. Position being, I think, the only property that this applies to. So.
Right, but it's also the best one to visualize what's happening here. So the eternal conundrum of teaching this stuff.
So I hope people kind of get that about this direct manipulation and how we can really change the vibe of this stuff by. So for example, like if I start pulling the handles like this, it feels much more like a mechanical slide, right? It doesn't feel like gravity at all. And if we want,
and you're getting that hang at the bottom too.
Yeah. So it's a real kind of opportunity to test out and to play and to figure out, oh, when I do this, this is what it feels like. Shall we move on to example 2?
Sure.
Okay.
So yeah, there we go. So in this example, I've added squash and stretch, which is a basic animation principle here to kind of really help you feel the weight of the bounce and get some, some reinforcement of that impact that's happening here. And so in this case, if we were to have motion blur turned on here, it actually kind of destroys the illusion that you're creating by doing the squash and stretch, because it's then sort of like making a weird blob that no one wants.
Yeah, and it's like, so if we go back to this first example, and we put our motion blur on, this is sort of providing the schmears that we would desire, right? That are in cartoons. If you pause on one of those cursed frames, you'll see like 7 eyeballs and the face is just mushed across the screen.
Yeah.
Well, that's...
But looks right in motion, and that's what matters.
Exactly. So the motion blur helps us...
Especially in the time before everyone freeze-framed everything.
Yeah. Yeah, when you only had a VCR, it was more difficult to step through. But yeah, like the squash and stretch, like the stretch is the smear. So it's like we're putting a smear on a smear.
Right. Exactly.
But yeah, I don't know. Talk a bit more about like the velocity changes in here, because if people are sort of applying this, what are some like rules they should think about?
Right. So one thing I'll point out is that the position keyframes here are eased exactly the same as in the previous comp that you just saw. The bottom value is tweaked a little bit because the actual once you start squishing the thing out, you have to move it down a bit to kind of compensate for that. But the curves are the same. But what you're doing is, if you maybe want to just kind of frame by frame through this here, you'll kind of see when it's up at the top, it's a perfect circle. And then basically the idea here is the faster the thing is moving, the more you stretch it out. But if you say, squish it by 50% in this dimension, you want to stretch it by 50% in the other dimension. You want to maintain the same mass on the thing so that it looks right.
Mm-hmm. So we're just going to go into the speed graph so that you can see here when we look at the positions of these, this point of maximal acceleration, right? Mm-hmm. Which frame are things feeling the fastest on? And that's what the speed graph tells us. It tells us that really nicely. So if you're trying to compute when should things be the most stretched, look at the old speed graph. You'll see a hump or a peak. That's the place to stretch or exaggerate the most, I suppose.
And honestly, that one on the right maybe shouldn't be that stretched yet. It should probably be that stretched a little further down, but
well, that's kind of the
it felt right when I was making it. So
yeah. Well, look, the people of the chat are having a schmear debate.
They are.
On the West Coast, it's one way. On the East Coast, it's the other.
Well, I think anyone on the East Coast would laugh at anyone on the West Coast thinking that their bagels qualify as bagels. So it's a whole
sick burn. So that's right, LA. We're calling you out here on the show. So I know we've got a lot of examples to roll through. So we might as well let's get into something practical. Maybe the first kind of test. We've bounced some things. Let's actually make something that looks real and good.
So let's turn those two off and look at ball A here. You can turn off that guide layer number 1 as well. Evan's driving today because we didn't want to test my my Wi-Fi here at rental condo by having me do After Effects as well.
Yeah, that'd be. Let's get into challenge mode while we're at it. So
ball A here. Let's highlight it so we can see. This is that exact same bounce yet again. I think this is actually bounce 2 from that you've seen in the previous comps. It's just the same thing over and over, but we added some X movement. Okay. And obviously a ball isn't gonna bounce that way, but the trick to doing a nice ball bounce is that once you add that X movement, then you go through and you can do this either in the value graph or directly on the screen with your motion path. It's going to kind of work the same way here. If you kind of take each bounce and drag it to about half the height of the previous one, you're going to start getting a pretty good ball bounce. And of course, the bounciness of the object, the bounciness you want to communicate about this object will kind of determine how fast it rolls off here. Let's see what that feels like. It's going to feel better, but still weird because obviously the X isn't really eased properly here. And there's a few more steps to get to this, but I feel like maybe we could just kind of step to the real thing you need to do is work with your timing because each bounce should get a little shorter in time as well. So if you want to step to B there, you can kind of see, let's maybe look at the keyframes real quick. Compare the keyframes on the 2 layers. Might be good.
Yeah, let's get that, at least the Y positional change, because that's probably the most different.
There you go. And so you can see the similarity of the bounce, but also how far apart they still are on that one layer versus the other one, where each one, it's not only going half the distance, but they're getting closer and closer and closer because, a little bounce isn't going to take as long as that great big one.
Yeah, it really it gives it weight, right?
Exactly.
The inertia, it's decaying. Each bounce can't get you as high anymore. So you need to get more bounces back to back to back to experience the same type of highness. That's anyway. So
yep, we'll just leave that there.
So,
and then,
but ball B, right?
One other technique. Go ahead.
I was gonna say you've also got this rotation in there that compounds this
I
feeling.
felt like I should add that. Yeah, exactly. Because it, when it's just a sort of a dead circle, it doesn't feel as real. And so I just added this little cutout here with some rotation, which, probably isn't 100% accurate. I just kind of did it, close enough. But especially there at the end, where you can really see it slowly rolling, you can just see it slowly, come to a stop. And I see Mike just brought up in the chat, of course, you can bounce things with an expression as well. And we were talking about that before the show. Absolutely. There are expressions that can let you bounce and do elastic and stuff. I think the thing about that is, one, it can be a crutch and keep you from sort of learning how to do this stuff properly, because there are times where you can't solve it just by copy pasting the expression in here. And the other big issue is that if you need to do several of these, the processing involved in that can build up if you have a lot of layers. So it's good. One of the great things about After Effects is you can do a lot of things like 3 different ways. And so the more ways you know how to approach a thing, the more you can sort of solve that creative or technical challenge when it comes across, right?
Yeah, and like, I mean, beyond expressions, there's also there's like physics plugins that you can explore as well, like
Exactly.
Newton, and I think Physics Now is still going strong. There's probably a few others. If you think about it,
I'll tell you, Character Animator has a physics simulator built right in, and that's super fun to play with as well.
yeah, and it's streamlined to do that, right? Like, that's what the system's been streamlined to do. The more expressions you add, the more lines of code you have. They're evaluated on every frame all the time, and especially something like inertia, because inertia in a vacuum never dies, right? It's always going on. And say like, oh, we've only got 4 things and they're bouncing, right? Yeah, well, that's about 120 lines of code that you're evaluating each time. So of course things are starting to slow down. Sometimes with those things you would probably want to then bake the animation if you are having slowdowns.
Right.
But it also locks you into making things that are real. Hold on, I'm gonna put these close to my face so I can.
That's an excellent point, and I think I don't want to quite hop to the next example yet, but that's going to be a perfect thing to talk about there in a minute. I want to show one other technique before we get away from this ball bounce, though, which is that top layer there. Let's turn off layer 2, but so I just made this little white box. Like, why would you do that?
Yeah, what is this?
And it's just a position move, right? But if you open up the graph editor, you can see that, and then layer 3.
We'll get that.
So we actually just want to see the Y positions on both of them. There you go. I'm using that first layer as kind of a guide directly in the graph editor. And so this can be a good way to kind of give yourself a visual representation of what you might roughly the curve that you're trying to approximate with these bounces. And so especially if you're kind of trying to do a more extreme fall off or keep a very bouncy thing that still has sort of a realistic trajectory, you can tweak the one curve, just, because this is just 2 keyframes of this guide here, and make it very extreme or very flat or whatever. And then you can kind of try to use that, sort of trace that with your bounces as a way to nail the easing of the bounce, essentially.
Yeah, and it's one of these things where we can kind of pull it up and down from the line over here. We can pull it around there.
Exactly. You can always tweak it. It's just there as a reference.
And one of the things, so we're going to jump away from Kyle's stuff. We're going to look at some Evan's stuff here for a moment.
Sure.
Because we're talking about...
You're in control. I can't do anything about it anyway.
Ultimate power. So I want to talk about a little bit, we're talking about the feeling and the weight of things and the perception of things hitting and bouncing. So here's a nice little example where we've got some arrows that are sticking into a target, we'll say. And exactly. Bringing the Foley work today.
Do it every time you play it. Yeah.
Fatoing, shoosh. Also, good morning, Roland, and shout out to South Africa. How's it going out there? People from all over the world coming in, learn about keyframes today. So all of these things, all of these arrow hits, they all take 1, 2, 3, 4, 5 frames to get from off screen to the target. But they all feel very different, right? Funk, funk.
Yep.
So this one feels really slow. Then this one feels quite a bit faster. And of course, it doesn't really enter the frame until right here. So it's chilling out, and then
Mm-hmm.
so it's really only with us for like 3 or so frames. But that's because
So you really eased out of that
exactly. So
keyframe
we are
there.
easing
Mm-hmm.
out of this first frame here, and we can even slack this off a little bit so that it shows up here in the first. So we got a little peak of the nose like that.
Mm-hmm.
But what it's doing here is it's telegraphing, hey, I'm hanging out. Oh, I'm still hanging out. And then it's really going. So it's like we register.
And I would say that that feels more realistic because in the real world, it's coming off of a bow and it's taking, a few milliseconds, maybe less than that, to accelerate from 0 to its full speed,
Yeah,
right?
it's hitting all those air molecules and chopping them in half,
Mm-hmm.
breaking the sound barrier on the way through. And like that feels a lot better. It takes the same number of frames to get there, but because of that easing, it feels stronger and it like
I
it
agree.
stops, like it abruptly stops at that thing instead of like linearly stopping or
Yeah. Brr.
you're slowing to a stop, right? It's like it could have kept going, but it's been interrupted. So
Mm-hmm.
then this last,
Good way to describe.
sorry, go ahead.
I was just agreeing with what you
okay.
said. That's all.
Well, good. I mean, we only accept agreement here on this program. So this last one takes that one step further, that it's accelerating in, and then it's wub 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 wub, showing that it had the inertia, and that that inertia has to go somewhere. So the place it goes is into rotation side to side. Like it is saying, what am I going to do with all that extra energy? Well, it's going to go here, and that's going to tell us, man, that arrow must have been going pretty fast because it still has juice left over when it hits, and it feels good.
So much energy that you have to animate another property to help communicate how much energy you just arrested.
Yeah, exactly. It's overflowing with energies. So how do we achieve something like this pretty easily? Well, we want to start here. I'm going to clear those out. We're going to start with the rotation at 0, and let's say we start here where it's actually hit the target. I'm going to set a keyframe there.
Let's.
I'm going to move ahead a bit, and I'm going to say, let's go to like 5 degrees or something. Move ahead a bit more, and we'll go here to -5 degrees. And I'm going to jump into the graph editor, and we're going to observe the value graph. So you can see we're starting at neutral. We're going up by 5, down by 5. And we'll just zoom in a little bit here. And I'm going to select these two. I'm going to copy them, move ahead a bit, and we're going to make like a sawtooth.
This looks a lot like a bounce curve almost.
Yeah, so we're going to go, whoop, hold on, doop, doop, doop. So we want to be selecting, right? We're going up, down, boop, and then.
And this is a great thing to sort of point out what Evan's doing here. He's selecting and working with keyframes directly in the graph editor, which you can do. And he's going to do something else in a second that's even better.
We're going to grab them, we're going to pull them around. It's crazy. So this type of a thing, wub, 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 that's not exactly what we want, but it's close, right? We're getting closer all the time.
Let's start.
And yeah, we work it up like painting, right? Like it's starting broad strokes. The timing is correct, but the values are not correct. So I'm going to select all these values, and we have the bounding box turned on, so you can trigger that. And I could say, okay, let's make it last longer. Let's make it go shorter so we can expand and contract it like that. So if I
just stretch out that whole group.
Yeah, stretching that group. So there, it's nice and slow. Whoop. Or we can even drag it around, right? You can select different elements and drag them places. And another thing that's fun, it's a bounding box. Behaves like any other bounding box you're going to be sort of working with. Hold down Option, click on a corner, and would you look at this? We can change this.
Yeah.
This is the magic. We get something like this. So now it's decaying like that. The values are closer and closer and closer to 0 as they come together. So now it looks like that. Perfect. If you then deselect and then reselect everything, the bounding box is reset, so it's easier to squish these things. But then I just ease them. It turns into a nice looking decaying wave.
What key did you press to do that?
I hit F9 just to make that happen.
Oh, yeah.
But of course, I'm a huge nerd, so I've got this mouse here with a little button on the side that I've got wired to.
I mean, that makes sense.
We use it all the time.
Because Exactly. To really be able to get those handles easily, you just hit F9 or right click, keyframe assistant, easy ease, and now you've got these handles versus having to go to each one and use a pen tool to sort of pull them out. So that's sort of the step one of working with stuff in the graph editor.
Yeah, and it's what's really nice about these types of macros and repeatable commands. Like, I don't know, it's you wouldn't think like, oh, it's you're just moving your hand like this. Like, well, anything that disrupts your flow with some kind of motor neuron requirement, that's going to be pulling you out, right? It's pulling you just a little bit out to have to do that, unless that muscle memory is built up. But anyway, speaking of muscle memory, though, if people have not tried adjusting over to the new properties panel that's hanging out over here, it's a great way to sort of set our keyframes initially, because you can set all of them in here. Anyway,
you can set all your keyframes from there. Yep.
So,
yeah, +1. It takes a little while to get used to it, but it's worth it.
Yeah, and it's once you are doing it, you can clear up a lot of your timeline clutter and stuff, because we're used to being down here, but it's roughing in stuff. You're gonna want to do it up over there. I'm trying to think.
I see your character and paragraph panels are still open, which seem pretty redundant now.
Look, I reset us to the default view because we're teaching.
Put you on the spot here.
Oh, look away, look away. So I want to talk a little bit. The other thing that we've got here, we talked about separating of dimensions, right? So you can separate position. If you call up a positional property, you can right click on it and say separate dimension. This is something that is grayed out for all the other dimensions, unfortunately.
And I wish, speaking of things that are useful to see in the properties panel, shape layers. Boy, I wish the dimensions of rectangles and ellipses inside shape layers could be separated like that. Or the position properties inside shape layers also can't be, alas.
Yes. Put it on the list. put it on the list, send it to the devs. Top people are working on it.
But leading into one of the things Evan's going to show you in a minute, the solution he's going to show you works for all of those as well.
That's a tease. So we have here a few examples of scaling. So let's have a look at some uniform scaling in here. So we've got this little facsimile of an app window or whatever, could be anything. And the scale, if we come into our property here, you can see that it's just oscillating back and forth, similar to how we've done before. You can grab these things and grab the corners and stretch them out like so. And pretty good, right? It's popping up, it's wobbing around, and it's got that nice soft jellied finish to this. Oh boy.
Yep.
But it's still pretty rigid. So one thing that you might think is, well, let's kick that up a notch, and rather than having both of the values happen in the same direction, I will unlink them, which you can do over here. You can change that little constrain proportions. And if you come into the graph editor, now I've got them like a helix, right? They're like a helicoid. And they are coming from opposite directions and crossing each other. Now, they both live on the same keyframe, and that means that we can't separate their timing, but by separating the dimensions and having them go in opposing directions, it feels we're getting more gelatinous all the time with this, right? Like it's the same type of deal. Now, it is difficult to sort of
ask a quick question if it doesn't disrupt your flow too much.
Get in here.
Okay, so this is a good thing to kind of point out, because why is it that some things seem to move up and some things seem to move down when you're looking in the graph?
Oh boy. So these are sort of positive.
Well, without going too crazy, but.
Right. So we are currently observing a value graph, right? And so what we've got here, if we look at the red line is our horizontal component, I think. Yes. So the horizontal component is coming from above 100%, shrinking down to below, right, to 86, and then going up, and then going down, and then going up again. If we go into a speed graph, we also have negative speed, right?
Right, and this is one of the things that can be a little tricky, because you kind of think of speed as like a an absolute number, but After Effects does think of speed as being positive and negative
Yeah,
too.
and the best way to think of it is just magnitude away from zero. And if the number is growing or shrinking, that is going to determine whether you are above or below. And it's because in this case, it is percent change divided by seconds. So if the percent change is negative, we're still dividing a negative by a positive, which gives us a negative number. Hope that.
There will be a pop
Yeah.
quiz later.
Math. So if we go back to our value graph, just because it's a little bit easier to understand, we have this swapping places of the horizontal and the vertical. And if they're drifting away from the baseline by the same amount, it's going to have that conservation of mass that's going to make this feel like it's a full thing. Ooh, so full of burps. I'm a full thing.
Like I talked about in the squash and stretch earlier.
Exactly. So we're squashing and stretching this bad boy. Now we will go to the third form, a separated dimension, which feels a lot more liquidy again. So here we have all three of them together. Uniform, unlinked, and then separated. And the separated is, I have taken a little slider control, which you can grab from your effects and presets. Slider control, bring this out. You can name it whatever you like, which you can do by just hitting enter and typing on these things. I've named them X and Y, and those are simply holding values. If we call open the scale and we have a look at the little expression that's written on here, all we're doing is we are dragging in our values, our X and Y slider values, and then we're outputting X comma Y. Scale is a two-part thing. It needs a two-part response. So X comma Y gives us this. And what's really...
a thing called X will look at this. A thing called Y will look at that. And then send X and Y to this property's X and Y. That's all it is.
No more complicated than that. And if we come through here, and I'm just going to try to kind of reset this to be like, this is how it would have been. Right? Mm-hmm. So just grab these things and put them around like this. If we go ahead and we line up everything, it's going to be the same old story that we've already seen quite a lot. Big yawns. Why go through all that work, right? So this is very similar. Well, you can grab a bunch of these, hold down Option, and shrink it down. So now one of the axes is happening faster than the other. I'll just grab both of these and go like that. And now we're getting something interesting happening when the two of them are totally offset from each other. Now, the idea here would be, well, there's more tension across one axis than there is off of the other. So that's going to give us this kind of uneven, almost circular type of movement in here. And as long as you don't compress this too much, so if you go a little bit too much, it starts to look a little bit funny.
Yeah, getting weird.
It's getting weird now.
But having them slightly offset just adds to the visual interest of it, even if they're just off by one or two frames.
So if you're ever like, this feels a little bit too robotic, this isn't quite what I want, think about splitting up the dimensions, because as we've seen, the amount of inertia spread over different properties is conveying more inertia, more interest, more character, and then separating the dimensions is giving us more interest and more character. So hopefully these are helpful ideas when it comes to this. Kyle.
I think they are, but I'm slightly biased.
I don't like any of what you guys have said so far. I hate keyframes. I don't know. Is it time to show people the ball inside a shape? What do you think?
I think probably. Okay. I don't know, good people. Do you want to see ball in a shape? Should we wait 24 seconds until the comments catch up? No.
Plus or minus whatever our voice offset is doing.
Right.
Listen, let's get into it here. We have limited time. We can't.
So let's take a look at the keyframes first, just so people can kind of see what's happening there. So we have a hexagonal shape with one side missing, and sort of a little, arm, and then we have a ball. And I've added just kind of a colorful echo schmear onto that, specifically so you can really visualize what the ball is doing. And this is a good example of like this kind of movement, you can't separate the dimensions and actually work with this. And so you have to know how to work in both graphs. Some people get very like, oh, value graph, speed graph, like it's a weird rivalry for some reason, but you have to know how to use both for the different contexts when they come up. Because this is a situation where you have to be animating where the screen position is so that it looks right, and then figure out how quickly it needs to move between those things and sort of the hang time on each of these bounces that it has. And ultimately, it's just about making it look right.
Yeah.
But I think you mentioned earlier, there are physics plugins and stuff that can do some of this stuff. And I admittedly did use one of those to kind of help me get the skeleton of what this should probably feel like and how the ball might bounce around inside the shape. But then I tweaked it from there using the speed graph.
And yeah, if we got the speed graph up right here, so you can see where it's at. And these kind of like, how to say, almost, we'd say like almost non-intuitive the way this stuff works sometimes. Like if you just looked at the speed graph and you had to try to decode what was going to happen from looking at it, that could be really sort of difficult.
Yeah. And I will say, that you may look at this and decide that you would have done this differently, and that's totally okay. One big thing here is, and I think you should specifically like pick one of these bounces and tweak it in different directions to help communicate this. You are showing your viewer how bouncy this thing is, how heavy this thing is, like maybe how elastic the hexagon shape itself is. If you wanted to take this further, you could have the hexagon shape be rubbery, and you could be like, bending those paths every time the ball hits it. Like this could be taken to a much further level, but then that's that much more energy that you have to sort of put back into the thing every time it moves away from the other surface.
Yeah,
right?
So I'm going to go ahead and I'm going to stretch this one here up, right? So this 1 point, boing. So hopefully you can kind of see that this feeling, this kind of U shape that we have between all of these, right, is that it's fast and then it's slow, and the fastest points are where it is colliding with the shape. So that's telling us that this is bouncy, right? Because the slower it's getting like a pinball machine, right? It's gaining padoink, padoink off of each of these things. So that's something that the graph kind of tells us as it's going. What are the...
So Roland is saying for something like this, he prefers using the value graph. Do you want to switch to the value graph and see how that looks on something like this?
Yeah, and it's a little bit more difficult for us to sort of modify, right? We would have to unlink these, which we'll just go ahead and...
Right, which is going to destroy all the curves as well.
Yeah, and as long as the point remains in the right place, right, I can adjust these handles. But what you're getting, you can see the motion path kind of getting tweaked and strange.
I would, yeah, exactly. I would find it very unintuitive to try to tweak X and Y separately for something like this, because they're changing so drastically every time it bounces around.
Yeah.
This is so much more about like making sure the motion path is correct, and that it's moving in the way you want, and then adjusting the speed graph to I so that it feels like it's moving in the air quotes correct way, whether that's actually like realistic or cartoony or whatever is right for your
And now
project.
One thing that I want to show here, you can see that when I grab this and just kind of pull it around, it's creating 2 points on the same, it's like splitting the 1 point into 2 points. If you don't want that to happen, you need to double click on this and click on continuous. And that's going to get these two things kind of locked onto each other so they cannot be separated. So they will always have the same velocity in and out. Now, one of the reasons that I sometimes do that is, let's say I grab all of these. I'm going to easy ease them all, totally ruining all of Kyle's work.
That's okay.
Then I want to make them continuous, right? So select these things, making them continuous. I think that worked for everybody. Yes. So let's say that we're coming in here and we have a certain velocity. So right now they're like really like, oh, I'm gingerly stepping onto the onto the
Right.
thing, right? I'm mincing around. That's not what I want. I can drag these things up off of the floor, which we will do by simply
Because coming all the way to 0, it often doesn't look
no.
right.
So let's get them off the floor. Still not quite right, right? Because remember we want U shapes, right? We want U shapes like this. Boing boing boing.
Me
Yeah,
shape.
me shapes. And then if we want them to feel like they're decaying, you bring
Each one.
each one
Exactly.
is just coming down a little bit at a time like this. So now
So you can kind of see why I did it funky, because that last one where it falls out kind of wrecks everything else.
whee! So
And it realistically should accelerate as it comes out of
exactly.
that.
So anyway, all this to say, when you're manipulating these graphs, being able to envision what the graph means and what it's telling you, and when you change it, what does that mean? Like, I think that's the key to success with manipulating either of these graphs. And it's
I agree.
like trying to translate a language, right? And you sort of have to do these strange kind of beginnery exercises in order to really get conversational with it, right? We start from building kind of simple exercises.
Speaking of the beginner exercise, don't you have another
I do.
example?
Speaking of things that are
That was supposed to be more of a burn, but
yeah.
you just
Speaking of juvenile
You're too
things,
nice.
how about this? So here, let me go ahead and take my echo off of this. I want to talk about a type of keyframe that we have not covered and that was specifically called out in a question to us. They wanted to know about roved keyframes, roved or roving keyframes. And these are keys that have a place but not a time. They are
yeah.
a key out of time. My short fiction coming soon.
They have a time, but their time is dependent on the unroved keys
Exactly.
around them, I guess.
So let's look at a pair of these keys. So for example, if we go from up here to down here, I'm going to just purge away everything else for now.
Be gone.
And you can see that we've got one eased key here, we've got another eased key there, and we've got two little circles in between. If you want to sort of just make them whatever keyframes, I'll just go like that, and now they're eased keys. But if you take any keys, you right click on them, and then you say rove across time, now they're going to do this. And when you come into our graph editor, we're observing a speed graph at this point. If I start grabbing this handle, you can see those little yellow circles sliding along, right? It's like this is a thread, and we've got these two kind of gates, and we're pulling the thread through the gates. You can see the little string going through like that. And these have a definite place in the world, but they don't have a definite time, because when we're going to arrive at those is being determined by the influence of the things on either end. I don't know. Kyle, when would people want to use roved keys? Why would someone want this?
I say for myself, it's definitely something like this where you're going along a motion path and you maybe aren't sure when it needs to, pass those certain points or curves or something, but you want it to all feel continuous like this. You definitely need to pass those spatial values, but you want it to kind of flow properly. And rather than trying to pinpoint exactly when that should happen, which is sometimes between frames, which could be tricky, this is the good option.
And so Umacorn is asking, the tiny dots in between indicate the speed. Yes, they're actually telling us where this object is on each actual frame. So these are the interpolated frames. So you see we're jumping from dot to dot to dot on each frame that we go through. Now, of course, these things are riding the line perfectly. If I wanted to do this and not rove them, I'll just grab them and de-rove them here, right?
There you go.
And this is how I would have to construct the curve to produce the same feeling of results, which gets a little bit more difficult when I start grabbing some of the ends here, and you can see, oh, well, now that's getting strange, and that's getting strange. And if I want to modify this...
Did we determine you can rove keys that are not position, or are those the only ones you can
I
rove?
think these are the only
Try
ones.
to remember. I think so.
And one reason why you might not want to is, let's say I wanted to decelerate. Like these are the
Exactly.
these are the curves, right? Well, if I'm a car, I need to kind of slow down in the curves a little bit like that. A little F1 fact: you want to accelerate out of the curve. So we can do exactly that with this. So we're gonna slow but not stop in the curve, right? So shoom, 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 like that.
Yep, that feels nice.
Now let's pinch these together and say, now Evan, you said accelerate out of the curve. Okay, so I'm going to push all of our keys like this, so that the point of acceleration is out of the curve. So we're slowing into and then accelerating out of. So just like that.
Hang on.
So yeah, this is a great way to sort of figure it out. Now, if you're wondering, Evan, how do I create this sort of thing, right? Like, how do we end up getting there? Well, let's say, for example, I have this path, this motion path defined by 2 keys, and I'm trying to get the shape that I want, but with
you just can't do it.
Can't do it with these 2 handles. You can just come in here and set a keyframe down and start moving it around. I like to just come up to the old pen tool up at the top, and then boop, click into here, or boop,
drag it around to wherever you need it to be.
Exactly.
Yep.
So now we can grab this and move it to the outside. We can switch it around like this. We can create all kinds of things just by dropping that in. Now that has created a normal type thing, but then you go rove it across time and it jumps in its timing. But it's just that simple, folks. It's just like that. Now, of course, we've only got a couple of moments left. Were there other things that I wanted to say about these roved keys? Ooh, okay. There is one thing that there's one thing that I did want to say. It's maybe a bit of housekeeping. If you enjoy these beautiful files, Kyle and I are going to find a way to get you these wonderful files so that you can play around and you can enjoy them at your leisure and dissect the stuff, right? We're going to figure out how to do that. The best way to make sure that you get those is to follow Kyle and I on the social medias so that you will know when we have such announcements for you. Do we want to try to cram? I don't think we want to cram another example in here. I think we did.
I could quickly show my hold keyframes, which is just sort of the flip side of all of these. So I made one more example using only hold keyframes, which just communicates a lot of energy, but without actually easing anything. And I just wanted to kind of show that as sort of a counterpoint to everything we've done here. You can certainly look at this in the graph editor and see the values, for example, but the speed graph would do nothing for you here because they have no speed. It's all hold keyframes. There is no interpolation happening.
Yeah, and you've got this lovely little detail, this little bump that this thing does before it starts moving that conveys like
a teeny bit
that something's going on. It's revving up. It's doing something. So even if you work with hold keyframes, you can still imbue a lot of life into stuff. So I hope people enjoy that. Anyway, we'll go back to the 2-shot here so people can really appreciate how out of sync our voices are. We'll get
and how much the sun has come out since we started the episode.
Kyle is now being roasted alive, so we must go so that he does not crispify. But yeah, make sure that you follow Kylosaurus Rex on Instagram and Twitter. Follow me on Instagram, Twitter at EC Abrams. We'll let you know how to get your hands on these delightful files if that's something you like. Most likely it'll be sort of a Dropbox link or something that we don't have to put a lot of energy into.
Yeah, we're working on something that's not too hard for us.
Yeah. And that we don't
Most importantly, if you have questions that you want us to talk about in future episodes, please send those in. Obviously, you can get us on the socials, but we have an official question form, which I've seen dropped in the chat several times. And if you have other stupid themes that you want us to do for episodes, you can just suggest that too.
Yeah, we're wide open to it. Wardrobe is limited, but as you can see, party time over here. So enjoy the rest of your days. I think we're the anchor of the stuff today. So come back tomorrow, Adobe Live. More great things going on all week long. We'll be back at you in 2 weeks. But until then, stay creative, be kind to each other, and we'll see you around the internet. Bye for now.
Bye.
Oh, this.